This is Le Chatelier's principle. And Le Chatelier's principle states that if a stress is made on a system at equilibrium, the reaction will shift so as to remove the stress. So it's just going to try to remove the stress somehow by reacting. So when you do problems like this, the questions you want to ask yourself is, what is the stress? Which direction will the reaction go to remove the stress? Towards the products or towards the reactants? Therefore, what happens to the compound asked about? So you're after point 3, and I'll show you an example right now. So here's our reaction, and you should recognize this as acetic acid, weak acid, with water to give us acetate ion and H3O plus. And the question is, what happens to the acetate ion concentration if the H3O is increased? So here's the question. What's the stress? One, the stress is an increase in the concentration of H3O plus. So that means it wants to get rid of the H3O plus. So to do that, we can get rid of it by reacting acetate and H3O plus. So we're going to shift these reaction to the left. So stress is increasing H3O plus. We want to decrease the concentration of H3O plus because that's what the stress was. So the reaction shifts. It means it proceeds towards the products. Okay? Now the question is, what happens to the acetate ion? So if the reaction goes this direction, if it goes to our left towards the products, then that's going to remove acetate ion. So the concentration of acetate will decrease. Let's do another one on this. So here's another reaction. We have N2 plus H2 yields NH3. And the question is, what happens to the NH3 down here if the amount of H2 is increased? So it's a real simple, same old process. One, what's the stress? The stress is increasing the amount of H2. Okay, so what's the reaction want to do? What's it want to do? Remove the stress. So it wants to, let me write it out, wants to decrease the amount of H2. The way it has to do that is to shift to the right. So the reaction shifts to the right towards the products, and every N2 is going to use up 3H2 to make an NH3. So we expect to increase the concentration of NH3, or the amount of NH3. All right, we'll do another one here. So here's our problem. 4HCl plus O2 is 2 water plus 95.4 kilojoules of heat. This kilojoules of heat over here means it is given off. And we can treat this heat, this 95.4 kilojoules, as a reactant. And that's what you need to do. This is exothermic, so you have to memorize that. If a reaction is exothermic, it gives off heat. So what's the stress? Stress is, one, increasing temperature, which is increasing the heat. You all know that. If you increase the temperature in the house, you get a lot more heat in there. Okay, so it wants to decrease the heat, and it does this by reacting from right to left towards the products. It will take 95.4 kilojoules of heat, two chlorine gas molecules, two water molecules, and it will produce 4HCl plus O2. And so the reaction shifts to the left, away from the heat. It wants to take that heat and use it up and get rid of it. The reaction shifts left towards reactants, and therefore the concentration or the amount of chlorine decreases. Let's do another one. So here's our next problem. We have carbon solid plus CO2 plus heat yields 2CO2 gas. I got that wrong. Carbon plus CO gas. So the question is, what happens to the amount of CO gas if the temperature is decreased? So one, the stress is decreased temperature. Two, we know it wants to increase the temperature, and that decreasing the temperature is the same as decreasing the heat. So it wants to increase the amount of heat. So it will go this way. It will make heat. Okay? So if it goes to the left to make heat, produce heat, that should have been equilibrium arrow, then it shifts the reactants once again, and we produce heat, but we asked what happens to the COs. So the COs, it decreases. It's a product. All right, one more type.